Very good evening, students.
Good evening.
Good evening, all of you. So, last class, if you remember, we have discussed about the concepts of purification, like sublimation, crystallization, distillation. In the distillation, we have seen four methods, like simple distillation, fractional distillation, distillation and reduced pressure, and also steam distillation. The other techniques of purification are solvent extraction and also chromatography. Solvent extraction or differential extraction. What is this? This is what I was saying. So differential extraction or solvent extraction takes place based on difference in solubility. First point. We have two layers here. Solvent layer, and water. You are adding organic compound. The organic compound in the aqueous layer initially present. When you add solvent layer, the organic compound is going to solvent layer. What do you understand by this? By this, can I say the organic compound is more soluble in the solvent layer when compared to the aqueous layer? Can I say like that or not? Organic compound is more soluble if the organic compound in aqueous medium is separated by mixing it with organic solvent, in which it is more soluble than water. The organic compound is more soluble in solvent than water. So what happens if organic compound is more soluble in solvent than water? Then obviously whatever the organic compound we have in the water, that will come out of the already present interactions and it will develop new interaction with the solvents. The organic compound is going to develop new interaction with the solvents. Because of that, what will happen? In the solvent layer itself, we will be having all the organic compound. Organic compound will be present in the solvent layer. And in the aqueous layer, all the organic compound has been come out because the organic compound has new interaction with the solvent greater. So before extraction, you will be having like water in which organic compound is there, and you have just added solvents. The solvent will develop new interaction with the organic compound, and organic compound is taken to the solvent layer, and like that you can separate the aqueous layer and the solvent layer. Yes or no? So differential extraction takes place on difference in solubility. Organic compound should be immiscible with water. That is what first point. If organic compound is soluble in water, then why the new interactions are going to be developed? If water molecules and organic compound or organic solvent, if whatever the solvent you are taking, we have a solvent from the top, you can add anything. Yes or no? We have water layer. Here I am saying organic compound is slightly having less interaction with water. So that is why organic compound went to the solvent and developed new interaction with the solvent. And here you have a stopcock. Yes or no? From which you can open the stopcock and flow the solution. First point is organic compound is more soluble in solvent layer when compared to water layer. Second point is the solvent and water, they are also immiscible. If the solvent and water are miscible, then what is the point of taking out organic compound from the water to the solvent layer? That is not happening. Organic solvent should be immiscible with water. Organic solvent and aqueous solution are immiscible with each other. So they can form two distinct layers which can be separated by separative funnel, and the separative funnel will be looking like this. Right? If organic compound is less soluble in organic solvent, we are saying organic compound is more soluble in solvent when compared to water. But if the solubility in solvent is also slightly less, in that case we have to use very high amount of solvent, which is said to be continuous extraction. We have to do the continuous extraction. Benzoic acid can be extracted from its aqueous solution using benzene as a solvent. Benzoic acid can be extracted from its aqueous solution using benzene as a solvent. This is an example. Is that point clear to everyone or not?
Yes, sir.
Yes.
Right? Very good. So then comes the last technique known as chromatography. Chromatography, anyone can explain what is column chromatography? Have you ever seen column in the laboratory? So column will be similar to your burette. You have seen burette, right? You all have performed the volumetric analysis and all. Similar to burette, you will have column. Similar, not exactly same. Column is also similar to your burette. From burette, in the burette, if you add the solution from the top and keep it to the stand, why the solution come down? Because of gravity. Yes or no? Same thing here also. In the column also we have a long funnel like thing, like similar to burette. If you add the mixture of compounds from the top, they are going to reach the bottom. Now in the mixture we have A, B, C, let us say 3 components are there. Out of these 3 components, one component is attracted or absorbed greatly to the particular stationary phase. Like you are going from top to bottom, like 3 friends are there, A, B, C. All of them are going from top to bottom. But a friend 1 is attracted to the wall greatly. Friend 2 not attracted. Friend 3 least attracted. Whoever is attached with the wall greatly, he will not come down fastly. Whoever is not attached with the wall, he will come down. The same thing happens out of 3 components A, B, C. The component which has a greater absorption, that will come down slowly. The component which has lesser absorption, that will come down fastly. There's a difference in absorption. Chromatography is actually classified in 2 types: absorption chromatography and partition chromatography. We'll discuss that. This method is used for the separation of mixture into their components. Chromatography is obtained from the Greek word chroma. Chroma means color. Earlier, this is used to separate the mixture of compounds which are actually colored. That is why the name still is in existence. This method was first used for separation of colored substances found in plants. As I have told you, first used to separate the colored substances. This technique has 2 phases. Stationary phase. Stationary phase means the mixture of substance is applied on this phase. Stationary phase is a fixed phase. Fixed phase, it is not moving. Mobile phase, like a solvent or a gas, is allowed to move slowly through the stationary phase. There is one stationary phase fixed. Through that stationary phase, one mobile phase is moving. Through the mobile phase, the mixture of components move down. A solvent or gas is allowed to move slowly over the stationary phase. The component of mixture gets gradually separated from one another because of difference in the adsorptions. So let us understand the same points, whatever you have studied in the animation, you will get clarity. Look at this animation. So this is the animation for TLC. Just a second. We look at the animation for column chromatography. Yes. Yeah, this animation. Yeah, this is how your column looks like. It is not a burette. As I told you, it will be similar to burette. Initially, at the bottom, you will be having some glass wool. Above that, you have stationary phase. Above that, you have mixture of compounds which were dissolved in a suitable solvent. And above that, you have solvents. Let me show you again. Okay. See, this is your column. This is said to be your column. And in that column, you have at the bottom, you will be having some glass wool. What is that glass wool means? Because the flow of that particular component should not be very fast. Stationary phase, mixture of components, solvents. Stationary phase, mixture of components and solvents. And slowly the solvent is coming down. With the solvent coming down, different particles which were absorbed to different extents, they will come down at a different degrees. Like I can say, this is coming down slowly means it was stick to the stationary phase greatly. If a compound is coming down easily, that means it has no attraction or least attraction or least absorption. Like that, you can separate the 3 components or not? Yes or no? So we'll start with the discussion, students, again. So adsorption chromatography and partition chromatography, 2 are there. In that, we will have stationary phase or fixed phase. Fixed phase is kept in a particular column, and over the fixed phase, you will pass the solvent, which is nothing but a mobile phase. Mobile phase means something which is moving. The component of mixture gets gradually separated from one another. How is that going to be separated? We'll study. Based on the principle involved, chromatography is classified into 2 types. Adsorption chromatography and partition chromatography. What is adsorption? What is partition? We'll study. Adsorption chromatography is based on the fact that different compounds are absorbed on the adsorbent to different degrees. This is the main point. We have mixture A, B, and C. Let us say A sticks to this particular component greatly. B and C will stick weaker. If A gets adsorbed greatly, then B and C will come down easily, whereas A will not come down easily. If A is adsorbed, in some units we can say 100 is the capacity of A to get adsorbed. B, let us say 60. C, let us say 20. So which has least adsorption? C. If I am giving the extent of adsorption in the values of 10, 20, 60 and 100, the compound which is having least extent of adsorption, that will come down easily. So that can be separated first. The next, after some time, you will be getting compound B, that can also be separated later. After that, you will be getting the compound which has adsorbed greatly. So that will be A. So like that, a mixture A, B, C has been separated into A components, B components and C components or not? Yes or no?
Yes, sir.
Yes, sir.
Yes. So adsorption chromatography is based on the fact that different compounds are adsorbed on an adsorbent to different degrees. What are adsorbents? Commonly used adsorbents are silica gel and alumina. Why? Why we are saying adsorbents are silica gel and alumina? We have a mixture A, B and C. Generally these are the stationary phases. Why? Because what is glass made of? Glass is made of silica or not? Because the column, whatever you are thinking of, that is also made of silica. So stationary phase or adsorbents, whatever you are using, they are also made of silica gel. So that the interactions are going to be great. Adsorption chromatography is of two types. One is column chromatography and the other is a thin layer chromatography. So column chromatography is the column is similar to your burette and you will have the adsorption happening. So the mixture to be separated is placed at the top of stationary phase. The mixture which has to be separated is placed at the top of stationary phase. An appropriate element or solvent is allowed to flow down the column. So we have stationary phase like this, stationary phase. Above this you have the mixture, and after it you are passing some mobile phase which is solvent. This mobile phase is allowed to flow, and at the bottom you have some wool, so that immediately you cannot have the molecules coming down. Slowly they will come down. So since the solvent is coming down, along the solvent the mixture molecules will also come down. Due to gravity, everything is happening. In the mixture, one is adsorbed. A is adsorbed greatly to the stationary phase. B less than A. C is going to be least. So we can collect C first. After that you can collect B. After that you can collect A. Okay. An appropriate element means something which is flowing element. The solvent is allowed to flow down the column slowly. The strongly adsorbed substances are retained near the top, which are strongly adsorbed among A and B, C. If a particular compound A is strongly adsorbed, then that will be in the top only, and the substance which is weakly adsorbed, that will come down. So this is the animation again, the same animation which we have seen. So glass wool, we have stationary phase, we have mixture of compounds A, B, C, and then we have solvents. Solvent is coming down slowly because that is the element. Yes or no? Along with the solvent, the mixture of compounds also come down. That compound which is adsorbed greatly, that will be sticking at the top. Then you will have other compound, other color sticking at the bottom. The least adsorbed will be coming down bottom. So whatever the least adsorbed, that will be collected first. And then after slowly you can get the next adsorbed compound. And then after slowly you will be getting that compound which is strongly adsorbed, that will be obtaining a later phase. You may ask a question, sir, how do we know that we are getting only one compound or two compound or three compound? That is actually known because column chromatography takes a long time. If I am collecting one compound after 2 hours, let us say, after some 5-6 hours only the second compound will come out. So if it is just coming based on gravity, it will be very slow. That's why we have also placed some wool here at the bottom. Yes or no? So it is not going to be fast. It is very, very slow. The coming down of solvent from the top to the bottom, it will be very slow. And I personally perform this column chromatography HPLC as well. HPLC is high performance liquid chromatography. You can say high performance liquid chromatography means here we are having just a coming of solvents from top to bottom by just because of gravity. But if I apply pressure from the top, because if I want to perform this column chromatography in the laboratory, we used to perform in the night, like 12 o'clock, 1 o'clock in the night, and we come down in the next day evening, we collect the column. It will take some 12 hours to 24 hours. That much time it will take. Slowly it will happen. But that much time, if you can't wait, if you want to increase the productivity, you can use high performance liquid chromatography, where you will be applying pressure from the top. Because of the application of pressure from the top, the molecules are forced to come down bottom, that is come down bottom easily, so that you can do the separation fastly. Okay, is that clear, students? Simple technique based on difference in adsorption, different compounds have been collected differently. Then thin layer chromatography. Thin layer chromatography is also similar. So we take a thin glass plate. On that thin glass plate, you will just coat it with silica gel because adsorbent. On that, you will have a mixture of compounds ABC, right? That you will keep as a dot, and you will keep that thin plate in some solvent. Like how imagine this remote as a plate. I'll coat it with silica gel. After coating, I'll keep a dot. Dot means what? Mixture of compounds, whatever are there, they have to be separated. Somewhere I'll keep the dot here. I have a baseline. And if I simply keep a dot and keep this plate in this manner, will the solvent molecules move? No, because we have to flow some eluent. With the flow of eluent, with the flow of solvent only, the mixture A, B, C molecules, they are going to moving. So now what I am going to do is, I am going to place a plate in some beaker, closed beaker, where the solvent molecules will be moving up. With the flow of solvent molecules, the mixture ABC, like we have a plate in this manner, the solvent molecules are present here, solvent or eluent. Solvent is moving in this direction. Along with the solvent, this is coated with silica gel. Silica is coated means you have to coat a very small thickness, 0.1 to 0.2 thickness, 0.1 to 0.2 mm. Silica gel coated. And along the, because of the flow of solid molecules, this mixture, let us say A comma B comma C, they will also flow to different extents. So from the baseline, how much your solvent molecule moved and how much your respective organic compound moved, based on that we define one factor known as RF. Can anyone define what is RF? Anyone define RF? Okay, let us study. A glass plate is coated with adsorbent. Example, silica gel or alumina as a thin layer of 0.2 mm thick. That's what I have explained. And that plate, whatever you have thin plate, that is said to be chromatography plate or chroma plate. The solution of mixture to be separated is applied as a small dot. This is the dot of mixture which has to be separated. Some about 2 cm from one end of the TLC plate. This is TLC thin layer chromatography plate. The glass plate is placed in a closed jar containing the eluent. Eluent is solvent. It is placed in a closed jar. This all is placed in some closed jar because I don't want any effect from the surrounding. As the eluent rises up, as the eluent moves up, the components of the mixture, these components of the mixture, they will also move along the eluent to different distances depending on their degree of adsorption, because A, B and C are there in that mixture, right? A, B and C adsorb to the silica, right? So difference in the adsorption is there. If A adsorbed greatly to the silica gel, then it can't move with the solvent easily. If a C adsorbed least to the silica gel, it will move with the solvent easily. Yes or no? Understanding this point or not? As the eluent rises up, the solvent of the mixture move up along the eluent to different distances depending on their degree of adsorption, and thus separation takes place. Let us say C adsorbed least. So C will be moving greatly. A adsorbed greatly means A will be here only. B intermediate means B will be somewhere here. Right, students? So this is what the things look like. The relative adsorption of each component of the mixture is expressed in terms of retardation factor or RF value. The relative adsorption of each component of the mixture is expressed in terms of RF value. What is the value of RF? Distance moved by the substance from baseline. This is the baseline where I have kept the mixture of A comma B comma C. A particular compound A went to up to this particular distance. Let us say yes or no. And solvent is moving. Solvent is moving from the one end of the plate to other end of the plate. We have counted the distance of movement of solvent from the baseline. So RF is equals to distance moved by the solvent from baseline. Solvent is freely moving, it is not adsorbed, divided by distance moved by the substance from baseline divided by distance moved by solvent from baseline. Substance has been adsorbed, solvent is least absorption. So that is why it is said to be retardation factor. How much the substance is restricted to move. That retardation means stopping. Yes or no? Distance moved by the substance from the baseline divided by distance moved by the solvent from the baseline, that is said to be retardation factor. If retardation factor is high, then what you can say? If RF value is equals to 1, then I can say that particular component and the solvent, they are almost moving at the same rate. So in that case, the adsorption of that particular component to the silica gel is the least. Is that point clear to you or not? Retardation factor. Based on the retardation factor, you can estimate which substance went to which far. Distance moved by the substance from baseline divided by distance moved by the solvent from baseline. That is RF.
So,
Yes, please.
so how is this element moving against gravity?
It is not moving against the gravity, it is moving along the thin glass plate due to capillary action. Like in the paper also we have, like if you dip a paper in a particular solvent, what will happen? Along the paper also you have the movement of solvent due to capillary action. You know capillary action, right?
Yes,
In
sir.
physics,
Yes, sir.
yes or no? So that action is there. Because of that action only, it is these solvent molecules are moving. Okay.
Okay, sir. Yes, sir.
The spots of colored substances are visible on TLC plate due to their original color. Earlier in the previous days, it was these techniques were used to just separate the mixture of compounds which are colored. But nowadays, if the compounds are not colored in the visible range, then they are taken into UV light where they can show fluorescence. The colorless compound, if the compound is colorless, means it is not having any color in the visible range. The colorless compound which fluorescence are detected with the UV light. Amino acids are detected by spraying the plate with an anhydride solution. This example you have to remember. Amino acids are detected by spraying the TLC plate with an anhydride solution. Right, students? Is that point clear to everyone or not?
Yes, sir.
Yes.
Yes. So thin layer chromatography, chromatogram being developed. These are solvents. This is a baseline. I have kept the sample dot. Adsorbent, that is silica gel or alumina, that is coated on glass plate. This is the closed jar. And this is the developed chromatogram where from the baseline the solvent has been moved by some distance y, and a particular out of the mixture ABC, particular component moved by some distance x. This is nothing but developed chromatogram. This is nothing but developed chromatogram and thin layer chromatogram. This is TLC where chromatogram is being developed because solvent molecules are moving. This is developed chromatogram. Once the chromatogram has been developed, you can just find out the RF values and detect which particular compound is moving what type of distance. Same thing, same TLC if you perform with paper. In the paper, you will not be having, of course, coating. You can't coat a paper, right? But if you perform the same, similar to TLC, like element is there, you keep a mixture dot, solvent is moving up the paper, capillary reaction is happening. So in that case, what is going to happen is you call that as paper chromatography. If you replace the TLC, thin layer chromatography plate with a paper, that is said to be paper chromatography. The mechanism, everything is going to be same. Let us look at the animation. Understand this animation carefully, all of you. Stationary phase TLC plate. Yes or no? You have placed the plate. Mobile phase solvent. And you have closed it. Like different components have been taken here, but you can just take one component. Like different mixtures, like 3 test tubes are taken, right? In these test tubes, we have 3 different types of mixtures. So in every mixture, the solvent is moving and the components are moving to different extents. Based on that, you can actually calculate the retardation factor. This is for the first mixture, second mixture, and third mixture. Okay. Partition chromatography. Partition chromatography is based on the continuous differential partitioning of components of a mixture between stationary and mobile phases. Paper chromatography is a type of partition chromatography. Paper chromatography, as I was saying, it is also a type of partition chromatography. Difference between paper and thin layer chromatography is just in paper chromatography we have paper. In TLC we have a thin glass plate which is coated with silica gel of 0.2 mm thick. A special quality paper known as chromatography paper, not ordinary paper. There is some special quality paper known as chromatography paper is used. Chromatography paper contains water as a stationary phase. At the base of a jar, a suitable solvent acts as a mobile phase. Suitable solvent, due to capillary action, the solvent is moving up, and whatever the dot you have placed, which is containing a mixture A, B, C, those components are moving above. The solvent rises up the paper by capillary action and flows over the spot. The paper selectively retains different components according to different partition in 2 phases. The paper strip so developed is said to be chromatogram. Everything is same with the paper chromatography and TLC, everything is same, but here we are using paper. The spots of separated colored components are visible at different heights from the position of initial spot. Why? Because they are adsorbed. They have different types of attraction with the paper or with the water. The spots of separated colorless compound, whenever the colorless compound is there, you can use the UV rays, UV ultraviolet light, and by spraying different agents, you can actually detect that particular movement of different types of components from the mixture. This is again the paper chromatography in 2 different shapes, like 2 different types of papers we have taken. Chromatography paper, this is also chromatography paper like cylindrical paper. I have placed a spot that is dotted lines here, mixture, and I have solvent. Solvent is moving above due to capillary action. Closed jar is there, and you have placed a cardboard above so that you can hang the paper. This is a baseline. From the baseline, how much that particular mixture is moving, like different components of mixture are moving, we can calculate the respective retardation factor. Is that clear to everyone or not?
Yes, sir.
Is that clear, students? This is what chromatography means. Column chromatography, thin layer chromatography, and paper chromatography, they are in your syllabus. We do have other techniques, like I have told you, HPLC, high performance liquid chromatography, or GC, gas chromatography, and many other techniques are also there. Yes or no? So all those are not there in your 12th standard. So don't worry, whatever we are discussing, you be perfect with them. So after the separation techniques and looking at the animation parts, the next important point is qualitative analysis and quantitative analysis. Qualitative analysis means what? You have done salt analysis. Yes or no? You might be having given a particular type of salt. You have to detect the anion and cation in that particular salt. You'll do some preliminary test, confirmatory test. Yes, you can say this type of cation is there, this type of anion is there. All that you have studied. Now, qualitative analysis of organic compounds. Qualitative analysis of organic compounds means we have to detect the elements present in the organic compound. Just a detection, how much is there? That is a quantitative analysis. Like volumetric analysis you have done, right? You find out the concentration of a particular substance given to you, particular solution given to you. Quantitative analysis tries to explain about how much quantity of a particular element is present in that substance. Qualitative analysis tries to give idea about what type of elements are present in the substance. Qualitative analysis of organic compounds, detection of elements. The qualitative analysis of organic compound involves detection of all elements present in it. How to detect a carbon and hydrogen? Can anyone say? In the organic compound, if we obviously have carbon and hydrogen, how to detect them? Detection of carbon and hydrogen. Yes, please.
By heating the compound with cupric oxide.
Yeah, what happens? Why the heat? Yes, that's true only. By heating with CuO, what is going to happen? The carbon is going to be converted to respect to carbon dioxide. Whatever the carbon we have in the organic compound, that will be converted to CO2. The CO2 will turn the lime water milky. Whatever the hydrogen is there, that will be converted to H2O. The H2O can be treated with copper sulfate. Copper sulfate anhydrous will be treated with H2O. It will form CuSO4.5H2O. So colorless compound will be converting into color because CuSO4.5H2O is blue in color. So the carbon present in the organic compound will be converting into carbon dioxide. Hydrogen will be converted into H2O. The carbon dioxide, whether it is formed or not, how do we know? We can treat that with lime water. Lime water, if it is turning milky, you can say yes, carbon dioxide is there. If carbon dioxide is there, then carbon should be there in the compound. Like I have given a compound, whether the carbon is there or not, how to find out? We have to do that particular test. Hydrogen is there or not, how to do? You treat this CuO and then add anhydrous copper sulfate. And if you are seeing the blue color, because anhydrous copper sulfate, once it is reacting with water, it forms CuSO4.5H2O, which will be having a specific blue color because of DD transitions. Yes or no? So like that, you can detect the carbon and hydrogen present in the organic compound. Right? Carbon and hydrogen are detected by heating with the cupric oxide CuO. Carbon present in the compound is oxidized to carbon dioxide, which turns lime water milky. That is, C will be converting into CO2. C carbon of organic compound treated with CuO at high temperature, it forms Cu and CO2. That CO2 reacts with CaOH taken twice, it forms CaCO3. Lime water turned milky. CaCO3 is going to be milky white. What about hydrogen? Hydrogen will be converted to respect to H2O. Hydrogen present in the compound is converted into water, which turns anhydrous copper sulfate into blue. H2 plus CuO converts to H2O. That H2O will be reacting with CuSO4. That is anhydrous. Anhydrous CuSO4 is not having any color. But whenever it is hydrated, H2O acts as a ligand. Because of the presence of ligand, the d orbitals in Cu plus 2 that will be splitting up into Eg and T2G, where the DD transitions are possible. So you get CuSO4.5H2O, which is hydrated, which is blue in color. Is that clear, students?
Yes, sir.
Yes. So we can detect the carbon and hydrogen by treating with CuO and treating that carbon dioxide with lime water. Lime water can turn milky, or anhydrous CuSO4, which will be forming respect to blue color hydrated copper sulfate. After this, you will be having detection of nitrogen, sulfur, halogens and phosphorus. Nitrogen, sulfur and halogen. How we can detect? Anyone heard of Lassigne's test? Lassigne's test actually forms a sodium extract, sodium fusion extract you can say. Nitrogen, sulfur, halogen and phosphorus present in organic compound are detected by Lassigne's test. What is this test actually? Organic compounds are fused with whatever the organic compound you have. That organic compound are fused with a dry sodium in a fusion tube. Fusion tube will be like very small tube, like you can say 1 centimeter tube of thickness. You can say it will be like a very small tube thickness. You can say just not even half centimeter. Very small tube. In that small tube, you have to add the organic compound. How the sodium fusion extract is obtained means, like you have a very small tube. In that you will be adding an organic compound. In that you will be adding a sodium. Sodium is very reactive if it reacts with water. So that sodium, which is actually stored under kerosene, that will be added. Small sodium metal is added. Sodium element is also added. And you have to heat that particular fusion tube to very high temperature. Very high temperature you have to heat, and then you might be knowing the mortar pestle, right? All of you know the mortar pestle, grinding.
Yes.
Yes or no? So this total tube, whenever whatever it is heated to very high temperature, you add that to mortar pestle and grind it. That is nothing but sodium fusion extract. What is sodium fusion extract? You have a small tube, right? The glass tube. In that glass tube, you have to add sodium. While adding sodium, you have to be careful because it is highly reactive with water. And you have to add the organic compound, heat it to very high temperature, and then add to the mortar pestle, grind it. Whatever the compound you have, that is nothing but your sodium fusion extract. Sodium fusion extract also includes the glass, whatever we have been added. Understood this point or not?
Yes, sir.
Yes. So organic compounds are fused with the dry sodium in fusion tube and sodium extract is obtained. This is nothing but, okay, sodium fusion extract. Sodium fusion extract. The following reaction takes place. What are the following reactions? Sodium we have added. That sodium will be reacted with carbon and nitrogen. Carbon is present in the organic compound, and if the nitrogen is present in the organic compound, the carbon, nitrogen and sodium will form NaCN. If sulfur is present, it will form Na2S. 2Na plus S gives us Na2S. If halogen is present, they will form NaX. Like if organic compound contain nitrogen, sodium plus carbon from the organic compound plus nitrogen from the organic compound, you form NaCN. Na plus sulfur forms Na2S. Na plus halogen X2, it will form NaX. You may be thinking like these reactions are very simple, you can remember, but the logic you have to understand. What is the logic you are understanding? Sir, why you are preparing the sodium fusion extract? That can be asked. Someone asked the question, sir, why you are preparing all this? So if you think logically, in the organic compound, mostly what type of bonds are there, students? Covalent bonds or ionic bonds or coordinate covalent bonds? In the organic compound, whatever the nitrogen we have, that will be mostly covalently bonded or not? Covalently bonded with carbon. So nitrogen present in the organic compound or sulfur present in the organic compound or halogen present in the organic compound, they were involved in covalent bonds. Covalent bond is obtained by the sharing of electrons with the basic definition. Sharing of electron means overlapping of atomic orbitals or hybrid orbitals is happening. Understand this point, the nitrogen or sulfur or halogen present in the organic compound, to that we are adding sodium and heating it and preparing sodium extract. Why we are doing all this means, the nitrogen or halogen or sulfur which was involved in the covalent bonding, that has been taken out as an ionic species. Understand this, because sodium has a great tendency to form Na plus ion. The carbon in the organic compound and nitrogen, they were now released out as Cn minus ion. The NaCN will have electrostatic force of attraction. That means NaCN has what type of bonding? Ionic bonding. That means whatever the nitrogen we have in the organic compound that has been taken out in the form of ion, cyanide ion. Are you getting this logic or not? The nitrogen which was involved in the covalent bonding that has been removed out from the covalent bonding, and now we formed a respective ion, cyanide ion. Whenever an ion is formed, that ion has a greater tendency to form complexes, because the cyanide ion will now connect as a ligand. Yes or no? If you have an organic compound, in the organic compound there is no ligand, although we have nitrogen, because the covalent bonding is there. But the cyanide ion can act as a ligand. To generate cyanide ion, I am using sodium. Why I am using sodium? Because sodium has a greater tendency to convert Na plus ion. Now, if I have a nitrogen, I will be getting sodium fusion extract. From the sodium, in the sodium fusion extract, I can generate NaCN. And I am heating it to very high temperature. Why? Because I want to break those covalent bonds. Are you understanding this logic or not? It's not like understanding, yeah, sodium we have added, organic compound added, sodium plus C plus N gives rise to NaCN. That's not we are thinking of. We have to think why it is happening. The sodium reacts with carbon and nitrogen, and the nitrogen which was covalently bonded in the organic compound has been taken out in the ion like cyanide ion. So that the cyanide ion can act as a ligand and form different types of complexes. Those different types of octahedral complexes will have different types of colors. Based on the colors, we can say whether the nitrogen is actually present in the organic compound or not. Okay. So let us now go back to the reactions. So first a test for nitrogen. If we have nitrogen, let us assume. If we have nitrogen, then we have sodium plus carbon plus nitrogen will be forming NaCN. This is what will happen in the sodium fusion extract. NaCN is there. So now we are adding sodium fusion extract is boiled with a freshly prepared ferrous sulfate. Fe plus 2 ions are there. Fe plus 2 ions will try to form what type of complexes? Octahedral or tetrahedral? From your knowledge from coordination chemistry, what you can say?
Octahedral.
Octahedral complexes, yes or no? Sodium fusion extract is boiled with a freshly prepared ferrous sulfate solution and then acidified with a concentrated sulfuric acid. In the acidified condition, FeSO4 will undergo oxidation or not? FeSO4, where iron is in plus 2 state, will be converting into Fe in the plus 3 state or not?
Yes.
FeSO4 can be converting into Fe2SO4 taken thrice. That means iron from the plus 2 has been converted to plus 3, where we have H2SO4 present. So NaCN is obtained because of sodium fusion extract, and Na plus and Cn minus are there. Cn minus cyanide ligand. The cyanide will be reacting with Fe plus 2, Fe plus 2 and SO4 2 minus. Fe plus 2 is an ion which has a tendency to form octahedral complex. That means Fe plus 2 is surrounded by 6 cyanide ions now. That's what we say. Na4, because Fe plus 2 is surrounded by 6 cyanides. 6 cyanides. Yes or no? This is how the structure looks like, octahedral complex. That means we have Fe, Cn taken 6, whole iron should be in the plus 2 state. If iron has to be in the plus 2 state, this whole complex ion should have a charge of minus 4. If this whole complex ion has a charge of minus 4, then only iron will be in the plus 2 state. If this whole complex ion has minus 4, then you can say there are 4 Na plus required to 4 Na plus are required as a counter ions to maintain the charge neutrality. So Na4 Fe Cn6 is going to be formed. 6 NaCN plus FeSO4 forms Na4 FeCN6 plus Na2SO4. And this Na4 FeCN6 is formed. It is a complex with the Fe plus 2. But we are acidifying it. FeSO4 has a tendency to convert to Fe2SO4 taken thrice, because iron will be in the plus 3 state. Oxidation of iron occurred. So this Fe plus 3 ions will now be reacting with Na4 FeCN6 to form Fe4 FeCN6 whole taken thrice. This is what happens. Na4 FeCN6 plus Fe2SO4 taken thrice gives Fe4 FeCN6 taken thrice. What is the IUPAC name of this particular complex? It is nothing but ferric ferrocyanide which is Prussian blue in color. The Prussian blue color indicates the presence of nitrogen in that particular organic compound. Understood these reactions or not? The sodium fusion extract we have taken. In the sodium fusion extract, we have cyanide ion. The cyanide ion acts as a ligand, and we are adding FeSO4. Freshly prepared FeSO4 is heated with a sodium fusion extract. Fe plus 2 will be forming a complex with the 6 cyanides. Na4 FeCN6 is formed. Then we are acidifying it. Whatever the FeSO4 we have, that is Fe plus 2 ions we have, they are converted to Fe plus 3. FeSO4 is converted to Fe2SO4 taken thrice. That Fe2SO4 taken thrice will react with the already present complex Na4 FeCN6 to form Fe4 FeCN6 whole taken thrice, which is nothing but your ferric ferrocyanide. Because Fe plus 3 and Na plus you try to think of which will have greater electrostatic force of attraction. We have the same complex ion FeCN6 whole 4 minus. What is the complex ion? FeCN6 whole 4 minus, and we have Na plus, and Fe plus 2 has been converted to Fe plus 3. We have Fe plus 3 also. So Na plus and Fe plus, Na plus and this complex ion, Fe plus 3 and this complex ion, which will have greater electrostatic force of attraction. Obviously Fe plus 3, right? Because of more charge. Yes or no? Plus 3 charge, plus 1 charge. You can say Fe plus 3 has greater tendency to attract this FeCN6 whole 4 minus. So this new attraction is going to be dominant, and that is why Fe4 FeCN6 taken thrice is formed. What is the IUPAC name of this complex? No one? This complex I can write as 4 Fe plus 3 plus 3 FeCN6 whole 4 minus. So while naming the complex compounds, you have to name positive part first or negative part first?
Positive first.
Positive part. So I have to name positive. Iron I can write. Fe plus 3 is the iron. Do I need to give its oxidation states for the counter ions or no, not required?
Required, sir.
Required. Why, Faizan?
Because it's a d orbital, d block element, and it can show variable oxidation states. That's why.
That's why. Is that true? Or any
So there
guessing?
are two ions, right?
Two irons. Very good. There are two irons. No. Counter ion is also iron. Central metal atom is also iron. So it is. This is a must and should condition to define the oxidation state. So iron 3 and FeCN6 whole 4 minus you have to define. So 6 cyanides are there. Hexacyano. Iron in the negative. That is iron is present in the anionic part. So ferrate you have to write. Ferrate. What is the oxidation state? 2. Iron 3 hexacyanoferrate 2. Got it or not? Defined everything, right? Yes.
Yes, sir.
This test fails in the case of diazo compounds, like nitrogen is connected N double bond and N triple bond, and in that case this test is going to be failed. Why? Because the nitrogen of diazo compounds, nitrogen in diazo compounds will not be forming Cn minus ion, because we need NaCN, right? NaCN means Na plus and cyanide ion should be there. If cyanide ion is not there, obviously this test is not going to happen, because this whole total complex formation explained with respect to the ligand only. The ligand is formed because of sodium fusion extract only. In the sodium fusion extract, we are giving very high temperature and sodium is used because Na has a tendency to form Na plus ion. So whatever the nitrogen present in the organic compound which was involved in covalent bonding, that has been taken out in the form of ionic bonding, right? Same thing again with respect to sulfur. Test for sulfur, we have two tests. We can treat with lead acetate or sodium nitroprusside. If you treat a Na2S with lead acetates, you will get PBS. Lead sulfide will have what color? Lead sulfide will be black in color. Okay. Sodium fusion extract, because we have sodium and sulfur is there in the organic compound. Now we get Na2S. Na2S will have Na plus ions and S minus 2 ions. Again, the sulfur in the covalent bonding has been taken out by as sulfide ions. Sodium fusion extract is reacted with lead acetate, the Pb plus 2, and we have S minus 2. Pb plus 2, S minus 2 will form PbS. Lead sulfide is black in color. And you have CH3CONa. CH3CONa is nothing but is a salt of weak acid and strong base. Okay, sodium fusion extract is reacted with lead acetate. A black PPT of lead sulfide is formed, which indicates the presence of sulfur. Sodium fusion extract is treated with a freshly prepared sodium nitroprusside. Na2S is reacted with a Na2FeCN5NO. Appearance of violet color or purple indicates the presence of sulfur. Violet or purple color, that will indicate the presence of sulfur. Again, this reaction is going to happen. Na2S plus Na2FeCN5NO. This is nothing but your sodium nitroprusside. It will form Na4FeCN5NOS, which is a violet colored complex, or violet to purple colored complex is going to be formed. Is that clear, students?
Yes.
Right. In case both nitrogen and sulfur are present, if you have both nitrogen and sulfur, so they will form Na plus organic compound contains carbon, nitrogen plus sulfur. They will form NaSCN. That means we will have Na plus and SCN minus ion. Thiocyanate ion will react with which ion to form blood red color? Fe plus 3 or not. In case both nitrogen and sulfur are present in organic compound, sodium thiocyanate is formed, which gives blood red color with Fe plus 3. Fe plus 3 will be reacting with SCN minus to form FeSCN, and this FeSCN will be completely having a charge of how much? Plus 2, because Fe should be in the plus 3 state. FeSCN whole plus 2, which is nothing but your blood red color. No Prussian blue color indicates no free cyanides, no black PPT with lead acetate, no violet colored complex with the sodium nitroprusside. That means there are no free sulfide ions. That means when both nitrogen and sulfur are present, you will be getting respective blood red color with Fe plus 3 ion. If a sodium fusion is carried out with excess of sodium, whenever you are getting a blood red color, and you want to do the separate test for nitrogen, separate test for sulfur, then you have to add excess of sodium. When you try to add excess of sodium, what will happen? If sodium fusion is carried out with excess of sodium, the NaCNS or NaSCN will react with NaXS to form NaCNS will react with NaXS to form NaCN and Na2S. 2Na you can write NaCN and Na2S. That means whenever the nitrogen and sulfur both are present and you are having this blood red color, to detect nitrogen and sulfur separately, you take excess of sodium. If you take excess of sodium, the Na plus ions are going to be more. So Na plus or more means you get the thiocyanate ion is going to be disturbed into cyanide ion and the sulfide ion. So Cn minus and Na plus develops new interactions. S minus 2 Na plus develops new interaction to form NaCN and Na2S. They will show separate test. Okay. Separate test. Separate positive tests will be shown. NaCNS plus Na will form NaCN and Na2S. Na plus Cn minus Na plus S minus 2. So they will respectively, the cyanide and sulfide will respectively show separate test for nitrogen and sulfur. Right. So these are the tests for the detection of nitrogen and sulfur. Then we have halogen. If we have halogen, the sodium will be reacting with X2 to form NaX. So NaCl, NaBr, NaF, NaI can be formed. NaF we will not form. The fluorides can't be detected because respect to AgNO3, AgNO3 can also react with NaF to form AgF, which is colorless. AgCl, AgBr, AgI, AgF. Out of all these, because why I am talking about AgCl, AgBr, AgI? Because NaCl will be reacting with AgNO3. Silver nitrate will be reacting with respect to NaCl, NaBr, NaI to form respective AgCl, AgBr and AgI. What is the color of AgCl?
White.
AgCl, white color or yellow color? White colored PPT. AgBr and AgI, they are yellow color PPT. AgCl is soluble in NH4OH. AgI is insoluble. Understand this point carefully. We have NaCl, NaBr, NaI formed. NaCl will react with AgNO3 to form AgCl because sodium chloride will be reacting with the silver nitrate to form respect to AgCl, which is white PPT. White PPT formation indicates presence of chlorine. If you are getting yellow PPT, it can be bromine or iodine. Like AgBr and AgI both are yellow PPT, but AgBr is soluble in NH4OH, AgI is insoluble in NH4OH. Like that, you can detect a bromine and iodine. But AgI is not colored. AgI is not colored. It is not colored. Why? Due to AgI is having greater polarization or lesser polarization.
Greater polarization.
Ag plus is same. AgF, right? This is AgF. AgF, AgCl, AgBr, AgI. AgF will have greater polarization or lesser polarization? AgF?
Lesser.
Lesser, no? Because F minus is small in size. So the outermost electron density cannot be polarized. So it is not colored due to less polarization. Less polarization. Yes or no? So AgF is not colored. That is why we can't detect fluorine, but chlorine, bromine, and iodine can be detected. So AgCl is a white PPT. AgCl along with AgCl you get NaNO3. AgCl is soluble in NH4OH and forms a complex AgNH3 taken twice and Cl. AgNH3 taken twice Cl. And silver Ag plus ion based on the radius ratio I have explained one day. Based on that respective ions, Ag plus will be forming complexes of coordination number 2. I have given a table also. Which ion will form what type of coordination number complex? Ag plus will form coordination number 2 complexes. So why I am writing ammonia here? So NH3 plus H2O, that is nothing but your NH4OH. Because lone pair of electrons present on nitrogen, they will be attacking the proton, forming NH4 plus ion, and OH minus will also be having new attraction with NH4 plus. So AgCl plus 2 NH4OH gives AgNH3 taken twice and Cl. This will be positively charged and the chloride will be negatively charged. So AgCl is soluble in NH4OH because of the formation of this complex. If you take AgBr and AgI, they form yellow PPT. NaBr plus AgNO3 forms AgBr, yellow PPT. NaI plus AgNO3 forms AgI, yellow PPT. AgBr is soluble in H4OH, whereas AgI is insoluble in NH4OH. Like that, you can detect whether bromine or iodine is present. And AgF is not colored. That is why you cannot detect fluorine. Is that clear? So this is how you can actually detect the presence of chlorine or chlorine or bromine or iodine. Fluorine you cannot detect because AgF is not going to be colored. And next test for halogen, this is the Lessons test only, but we can also have other tests for halogens, which is nothing but Bale-Stein test. Anyone knew what is Bale-Stein test? In the Bale-Stein test, you will be taking some copper rod, and one of the end of the copper rod you flatten it and heat it until and unless it will not show any color. Like green color, blue color can be shown because of electronic excitations. Once you heat it to longer temperature, longer time, you will not be having any color seeing from that particular copper rod. That means there is no other substance, you can say. Now dip the copper rod or touch the copper rod with the organic compound and again heat it. What you are doing? You have take a thin wire of copper rod, flatten at one end. You keep it in the Bunsen burner flame, oxidizing flame. Let the temperature, let you heat it for longer time so that it will not show any color. After some time where you are not seeing any color because excitations of electrons are not happening anymore because there is no other substance present, dip into the organic compound, again keep it in the flame. If it shows either green color or blue color, that indicates the presence of halogen. Okay, so that is your Belton's test. A copper wire flattened at one end is heated in an oxidizing flame of Bunsen burner. Like you have the copper wire flattened at one end, the heating is continued till it does not impart blue color flame. The hot end of the copper wire is now touched with the organic substance and is once again kept in the flame. The appearance of green or blue color indicates the presence of halogens in the organic compound. Got it or not? Simple, right?
Yes.
Disadvantages are there.
Yes.
There are some compounds which do not have halogen but are showing this test, Bale-Stein test. And this Bale-Stein test cannot figure out what type of halogen is present, like chlorine present or bromine present or iodine present. That information we cannot say. There are some compounds like urea and thiourea. They will also show this type of Bale-Stein test. Limitations: substances such as urea. Urea will have what type of formula? NH2C double bond to NH2. Thiourea, NH2C double bond S, NH2. NH2C double bond to NH2, NH2C double bond S, NH2. Urea and thiourea do not have halogens, but they give this test. It does not tell which halogen is present, whether chlorine or bromine or iodine present. That is not given from this particular test. Right? So this is other test for your halogens. Then comes the test for phosphorus. Phosphorus, how you can find out, students? Ammonium phosphomolybdate is formed. Whatever the phosphorus we have, that is treated with an oxidizing agent like Na2O2 to convert the respective phosphorus to phosphate. That Na3PO4 you convert to H3PO4. That H3PO4 you treat with ammonium molybdate to form ammonium phosphomolybdate, which is canary yellow colored PPT. Okay, the reactions we'll study now. Test for phosphorus. The compound is heated in an oxidizing agent. Whatever the compound which has phosphorus, that is treated with Na2O2 to form PO4 3 minus. It will have electrostatic attraction with Na plus. So we can say Na3PO4 is formed. This Na3PO4 is converted to H3PO4 in the presence of some acid. This H3PO4 is treated with ammonium molybdate. Ammonium molybdate, NH4 taken twice, MoO4 converts canary yellow PPT. Ammonium phosphomolybdate. The solution is boiled with nitric acid and then treated with ammonium molybdate. A canary yellow nitric acid we are using, we can take H2S4 also, not an issue. And a canary yellow PPT formation that will indicate the presence of phosphorus in that particular organic compound. These are the reactions happening. Phosphorus plus Na2O2 gives rise to Na3PO4 plus Na2O. Na3PO4 treated with HNO3 to form H3PO4, phosphoric acid. That phosphoric acid react with ammonium molybdate. As I have told you, NH4 taken twice MoO4, NH4 taken twice MoO4 will be equivalent to NH4 plus ions. Along with this, we have MoO4 minus 2 ion. In the MoO4 minus 2, molybdenum is in which oxidation state? Plus 6 state. The higher oxidation state stability increases down the group or decreases down the group in D block elements. The stability of higher oxidation states.
Increases down the group.
Increase.
In the D block, in the P block, let us say first. Let us say group 15 or group 13. Thallium plus 1 state, thallium plus 3 state, which is more stable?
Thallium plus.
Thallium plus one
That
state.
means from top to bottom, the stability of a lower oxidation state is increasing, whereas higher oxidation state is decreasing. Why?
Because inert pair effect is coming in.
Inert.
Inert pair effect, we can say due to inert pair effect, the reluctance of NH2 electrons to participate in bonding. But in the D block elements, the stability of higher oxidation states will be increasing down the group. That is because in the D block elements, inert pair effect is not operative. We will be having the size increasing where you can lose the D electrons easily. Yes or no? So stability of higher oxidation state increases from top to bottom in a D block group like a 3b to 12b, 3b to 12th group, that is 1b, 2b. Whereas in the P block, the stability of higher oxidation state will be decreasing because of inert pair effect. So MO plus 6 is stable. So ammonium molybdate reacted with H3PO4 to form ammonium phosphomolybdate. NH3 taken NH4 taken thrice PO4 dot 12 MOO3. So this is nothing but your canary yellow PPT. This is actually your canary yellow. Because NH4 taken thrice PO4 means 3 NH4 plus ions will be neutralizing their charge with the PO4 3 minus ion, and we have 12 MOO3 where molybdenum is in plus 6 stage and oxygen should be in the minus 2 stage. Is that clear, students? Different tests test for detection of carbon, hydrogen, nitrogen, sulfur, chlorine, bromine, iodine, and phosphorus we have detected. Then we have respect to other tests also. Then we have the respect to quantitative analysis. Quantitative analysis. CO2 and H2O produced are weighed by absorbing in concentrated solution of potassium hydroxide and anhydrous calcium chloride or magnesium perchlorate respectively. That means like we have an organic compound. Organic compound is there. This organic compound is passed through the CuO. Okay. Organic compound passed through CuO means what is going to happen, students? Here you have one tube, and next we have another tube. We'll be having diagram in this fashion. Organic compound plus CuO, and you have one U tube like this, other U tube in this manner. O2, this is nothing but combustion chamber. This organic compound heated in the presence of oxygen in the presence of CuO, what happens? The carbon will be converted to CO2, hydrogen will be converted to H2O. The carbon dioxide being acidic in nature, it will be absorbed by KOH. KOH will absorb. KOH is a basic. KOH, potassium hydroxide is a base. Acid-base reaction will occur. So we have CO2 and H2O produced or weighed by absorbing in concentrated solution of potassium hydroxide. Here we have taken KOH. Here we have taken CaCl2. CaCl2 has a tendency to form hydrated complex because Ca plus 2 has greater hydration enthalpy. KOH will absorb CO2, and because of that, the weight of KOH is increased. And CaCl2 will absorb water. Because of that, the weight of CaCl2 will increase. Initially, whatever the weight we have taken, KOH and CaCl2, that no. Weight of CO2, what you can write down? Weight of CO2 is equals to weight of KOH plus CO2 minus weight of KOH. Can I say like this or not? Weight of H2O is equals to weight of CaCl2 plus H2O minus weight of CaCl2. This is the technique, students. We have CaCl2 and KOH placed in initially. That means we know the weights of KOH and CaCl2. We are forming carbon dioxide and water because we are heating the organic compound in the presence of oxygen and CuO. The carbon dioxide is absorbed by KOH, so weight of KOH increased. Initial weight of KOH, we know. Weight of KOH plus CO2, that is also we know. So weight of CO2 find out like this. Weight of H2O we can find out by weight of CaCl2 plus H2O minus weight of CaCl2. So using these two relations, I can use percentage of carbon is equals to, in the CO2, we have only one carbon, atomic weight of carbon is 12. What is the molecular weight of CO2? 44. 12 by 44 into weight of CO2 divided by weight of organic compound into 100. And percentage of hydrogen is equals to, in H2O we have two hydrogen atoms. So each hydrogen has atomic weight of 1. So two hydrogens 2. Weight of atomic weight of hydrogen 2 divided by molecular weight of H2O is 18 into weight of H2O divided by weight of organic compound into 100. Organic compound we have taken, so its weight we know. Weight of CO2 and H2O we can measure in this manner. 12 by 44 into weight of CO2 by weight of organic into 100. 2 by 18 into weight of H2O by weight of organic compound into 100. That gives the percentage of carbon and percentage of hydrogen. Got this or not? Yes, or no? So these are the techniques which we use to actually calculate the percentage of carbon and percentage of hydrogen present in the respective organic compound. Let us do a problem on this. On complete combustion, 0.246 grams of organic compound, this is the weight of organic compound, gave this much weight of carbon dioxide. Carbon dioxide weight also they have directly mentioned. And this much weight of carbon. Percentage of carbon is equals to 12 by 44 into weight of CO2 0.198 divided by weight of organic compound 0.246 into 100. Percentage of hydrogen is equals to 2 by 18 into weight of water 0.1014 divided by weight of organic compound into 100. Do the calculation, you will get the answers. Percentage of carbon 21.95, percentage of hydrogen 4.58. Got it or not? They have directly mentioned the weight of carbon dioxide and weight of water in the question. In case they have not mentioned, and they mentioned the weight of the increase in the weight of CaCl2 tube and increase in the weight of KOH tube is so and so. In the KOH tube, whatever the weight increase, that is the increase due to CO2. In the CaCl2 tube, whatever the weight increase, that is the increase in weight due to H2O. Like that, you can try to figure out. Clear or not?
Yes, sir.
Very simple calculations. Let us next to do at the quantitative analysis. This is the detection of carbon and hydrogen quantitatively, not qualitatively. Quantitative analysis, estimation of nitrogen. There are two methods. What are the two methods?
Dumas and Geldas.
Very good. In the Dumas method, what happens, Satika? You try to answer right or wrong, not an issue.
I don't remember, sir.
Okay, fine. Estimation of nitrogen. Nitrogen present in organic compound is estimated by Dumas method or Geldas method. In the Dumas method, we heat the organic compound containing nitrogen in the presence of Cu only, and nitrogen is released out in the form of N2. In the Geldas method, we treat with H2SO4, and then whatever the left out acid we have, that we will titrate with ammonia. With the help of titration, we will detect the percentage of nitrogen in the Geldas method. So let us try to find out here Dumas method and Geldas method. Dumas method. In this method, nitrogen present in the organic compound is converted to N2, molecular nitrogen. What is the formula we have? CXHYNZ. We are treating this with CuO. Carbon is going to be evolved in the form of carbon dioxide. Hydrogen will be evolved in the form of H2O. Nitrogen is evolved in the form of N2 gas. And the copper is released out. Try to balance this equation. To balance this equation, carbon is evolved in the form of CO2 means, can I say CXHYNZ gives XCO2 to balance carbons. Y by 2 H2 I have to write to balance hydrogens. NZ means I have to write Z by 2 N2. And what about the oxygen? Oxygen, how much we have? 2x plus y by 2. 2x plus y by 2 oxygens. So we have to write CXHY NZ plus 2x plus y by 2 CuO gives XaCO2 plus Y by 2 H2O plus Z by 2 N2 plus 2X plus Y by 2 Cu. So this is the equation which you can understand. Okay, in this method, nitrogen present in the organic compound is converted into N2 molecular nitrogen. And how it is converted? By treating with CuO only. A weighed amount of organic compound, that means we know what is the weight of organic compound, is heated with cupric oxide in an atmosphere of carbon dioxide. So carbon and hydrogen present in the compound are converted to CO2 and H2O, while nitrogen is converted to N2. Some oxides of nitrogen formed are reduced to free nitrogen by passing over heated copper gas. How the mechanistic approach will be there means we have a nitrometer. So we have CxHyNZ. We are passing this to copper gas. Here we have CuO. Everything is present here. Can I say the nitrogen is not directly converted to N2? There may be a possibility of oxides of nitrogen, N2O or NO2 or NO. These oxides of nitrogen, they are also formed. There is a possibility of formation of these oxides. These oxides of nitrogen are reduced to free nitrogen by passing over hot copper gas or heated copper gas. Why? Because these oxides of nitrogen will contain a double bond between nitrogen and oxygen. So those bonds you have to break means you have to give high temperature. This is like a furnace. Okay, CxHyNZ, carbon converted to carbon dioxide, hydrogen to water. Nitrogen is converted to N2, but in the process of conversion, there is a possibility of oxides formation. Those oxides are also reduced to N2. How? By passing over heated copper gas. This was the equation. CxHyNZ plus 2x plus y by 2 CuO gives rise to XCO2 plus y by 2 H2O plus Z by 2 N2 plus 2x plus y by 2 Cu. This is the same equation we have written earlier. Right or not? Yes. The mixture of gases produced is collected over caustic potash solution or KOH, which absorbs CO2. Whatever the mixture of gases we have formed, that is collected over, like we have what gases, students? CO2 we have, H2O we have, and we also have N2, right? This is collected over KOH. KOH will absorb the CO2 and N2 gas is released out. And whatever the pressure we are going to exert here, no, that pressure is also affected by H2O. Not only the vapor, the pressure of N2 is not directly evolved because N2 is also present with H2O. We'll understand the example as well. Nitrogen is collected in the upper part of nitrometer. Here we have nitrometer. In the nitrometer, the KOH is there. KOH will absorb carbon dioxide and N2 will be collected in the upper part of nitrometer. This is the formula. Percentage of nitrogen is equals to 28, because in N2 we have 2 nitrogen atoms. 28 will be the weight of nitrogen divided by 22,400 into volume of nitrogen in ml at STP divided by weight of organic compound into 100. There was a derivation for this particular formula, but you have to apply this formula carefully. That is very important. So what is the percentage of nitrogen? Percentage of nitrogen is equals to 28, because in N2 we have 2 nitrogen atoms. Atomic weight of nitrogen is 14, 2 nitrogen is 28, divided by 20,400, because any gas at STP will be releasing out 22.4 liters. So in ml it will be 22,400 into volume of nitrogen in ml at STP divided by weight of organic compound into 100. This you have to find out, volume of nitrogen in STP, but they won't give you the volume in STP. They will give the volume of nitrogen evolved at different other conditions. We have to find out this volume. How to find out this volume? Applying ideal gas equation. Let us solve an example, you get clarity. All of you try to solve. 0.3 gram of organic compound gave 50 ml nitrogen at 27 degrees Celsius, 715 mm pressure. If the aqueous tension at 27 degrees Celsius is 15 mm, calculate the percentage composition of nitrogen in the compound. What is the formula? Percentage of nitrogen is equals to 28 divided by 22,400 into volume of N2, volume of nitrogen in ml at STP divided by weight of organic compound into 100. This is the formula or not? Or any difference is there? 28 divided by 20,400 into volume of nitrogen in ml at STP divided by weight of organic compound into 100. Same formula we have written. Now what are known? 28 by 20,400, that is constant only. 100 is also constant. Weight of organic compound they have given to you 0.3 gram of organic compound. Only thing you have to find out is volume of N2 in ml at STP. So given conditions, what are the given conditions? 27 degrees Celsius. STP means what condition?
273 Kelvin.
That
1
is 0
atmospheric
degrees Celsius.
pressure.
27 degrees Celsius means I'll write 300 Kelvin. 300 Kelvin. And what is the Rayleigh's equation? PV is equals to nRT. Number of moles R is constant. So PV by T is equals to constant. So P1 V1 by T1 is equal to P2 V2 by T2. What is the volume here obtained? 0.3 gram of organic compound gave 50 ml. At 300 Kelvin, it gave 50 ml of N2 and 715 mm of pressure. What is the pressure of N2? Pressure of N2 is equals to pressure of N2 aqueous, pressure of dry N2 is equals to, because pressure you have to substitute only for N2, no, not for any other gas. Pressure of dry N2 is equals to pressure of moist N2 minus pressure of aqueous tension, because due to water. Because water is also there along with the carbon dioxide, water is also there. So whatever the pressure exerted, that is the pressure due to N2 plus H2O. So pressure due to dry N2 is pressure due to moist N2 minus pressure due to aqueous tension. That is pressure due to moist N2 is 715 mm. If the aqueous tension is 15, so 715 minus 15, that is 700 mm of Hg. This is a pressure due to dry N2 at what condition? At a 300 Kelvin, 50 ml of N2 evolved, moist N2, and that pressure is 50 ml of N2 evolved, and the pressure of dry N2 is 700 mm of Hg. Apply the next condition. P2 V2 by T2. What is the pressure? P1 V1 by T1 is equals to P2 V2 by T2. This is STP. Second condition is STP. P1 initial pressure dry 700, V1 50, T1 is 300. That is equals to P2 STP. What is the pressure, students? 760 mm into V2 volume of N2 at STP. We have to find out this divided by T2 at STP. What is the temperature? 273. So volume of N2 at STP is equals to 273 into 700 into 50 divided by 300 into 760. 273 into 700 into 50 divided by 300 into 760. That is the volume of N2 at STP. So this is the volume which required, that you can substitute. You can get the calculation. Okay. Volume of N2 at STP is 273 into 700 into 50 divided by 300 into 760. That calculation you have to do. Volume of N2 at STP is equals to 273 into 700 into 50 divided by 300 into 760. And we know the formula, right? Everything is known in the formula, just substitute it. So this much weight, if you try to calculate, here you will get a volume of 41.9. So you will get ultimate percentage of nitrogen is equals to 28 divided by 22,400 into 41.9 divided by our weight of organic compound is 0.3 into 100. That is 17.46%. You do the calculation, check it out. Is that clear, students, or not? Whatever the organic compound we have, that organic compound we are heating in the presence of CuO. Since we are heating the organic compound in the presence of CuO, that organic compound is releasing out CO2, H2 and N2. That CO2 is collected or absorbed by KOH. The left out is H2 and N2. So H2 and N2 will exert some pressure. Pressure due to dry N2 is equals to pressure due to moist N2 minus aqueous tension. That you can calculate. And in the formula of percentage of nitrogen, we have this formula is not obtained from bigger derivations, just like mole concept only. We apply the concept of mole, like at STP, 1 mole of any gas will be having 22.4 liters. 1 mole is equivalent to again molar mass. The same 22,400 ml of N2 at STP weighs 28 grams. From the mole concept only we get this. So percentage of nitrogen is equal to 28 by 22,400 into volume of N2 in ml at STP divided by weight of organic compound into 100. So do that calculation, you will get the final answer. Is that clear, students?
Yes, sir.
Yes.
Is everything clear? This is the first step. That is the first way to actually figure out the or estimate the percentage of nitrogen present in that particular organic compound. The next way is Geldar's method. So that we'll discuss tomorrow, because we can't start that again. The discussion takes time. Okay. So in the Geldar's method, we'll be using the titration technique. Whatever the nitrogen is present, we'll convert that into ammonium sulfate. In the Dumas method, the nitrogen is converted to N2. In the Geldar's method, the nitrogen is converted to ammonium sulfate. So we'll be having many compounds where the nitrogen cannot be converted to ammonium sulfate. Like you can say azodize, nitrogen in the ring like pyridine. For all those compounds where the nitrogen cannot be converted to ammonium sulfate, you cannot use Geldar's method. That is a technique which we are going to study in detail tomorrow. Fine. So these techniques are very interesting, and you try to solve a lot of problems, you will get command. Okay. And in the qualitative analysis, whatever the complexes we have written, you write down the formulae, respective colors, you have to remember all those. Also, we are understanding in the final exam, you have to directly answer the question. So better study them in detail again and again. Fine, students. Thank you all, everyone. Bye.
Thank you.
Thank you. Thank you, sir.
Thank you.